So this is the second time I get to do this video because I recorded it with no sound the first time. Way to waste 20 some odd minutes. This is 2.6 completing the square is given to us by the Babylonians. They did not have algebra per se, but they had methods of figuring things out. And they did study quadratics because they studied the heavens. Astronomy is quadratics by and large. So the idea here is completing the square works by forcing the left-hand side to become what we call a perfect square. And a perfect square, look at that math speak, is any trinomial in the form of x squared plus twice a times x plus a squared that factors as x plus a times x plus a, or x plus a squared. And you've done some perfect squares in class. You may not realize that you have, but you have. Uh, Let me just come up with an example. It's really easy when they're x squareds. But of course the numbers can't be too big. This is an example of a perfect square because of how it factors. You know by now, at least I hope you do, not everybody does, that it takes an x and an x create an x squared. And to create the 100, it's going to take a 10 and a 10, probably. Now, the reason it's a 10 and 10 is because 10 plus 10 is the 20 in the middle. And that's called a perfect square. If something's written twice, that means that it has been squared. So here's some examples, more examples of perfect squares. X squared plus 16x plus 64, how does it factor? It takes an x and an x to make a 64 is an 8 and an 8, and they're both positive, right? Because 8x plus 8x is 16x. I want you to pay attention to this piece. 8 is exactly half of 16. So pay attention to that piece. That's kind of the deal on creating the perfect squares. X squared minus 30x, you may or may not believe this, but if you take a 15 and you square it, you'll get 225. So it takes a 15 and a 15 to make 225, and they're both negative because negative 15 plus negative 15 is negative 30. And again, pay attention that negative 15 is exactly 1/2 of negative 30. That's part of the complete the square technique. All right, so now x squared plus 12x plus what factors as? All right, so I want to make this a perfect square. I'm going to take the 12 and I'm going to cut it in half and I'm going to get a 6. I'm going to square that 6 and get a 36. That's part of the technique, kids, is come up with a number that makes it a perfect square, because that's what the Babylonians did. But if I put a 36 there, I know that to make a 36, I need a 6 and a 6. 6 times 6 is 36. 6x plus 6x is 12x. Anyways, I've got the complete the square technique laid out step by step. And if you follow the steps, you're golden. In years past, my best students kind of quit doing the quadratic formula and they switch over to complete the square because it's quick. If you're good at it, it's quick. It's extremely quick. But not everybody gets there. All right, step 1, if a is anything other than 1, and by the way, a is an understood 1, divide all terms by a. Step 2 is to move the constant to the right-hand side. And if you jump equality, by all means and purposes, please change your sign. You'll notice Milbrath leaves space when he does that. That's because I've done this 1,000 times. I know what's coming. So we did that step. Step 2 is divide b by 2. Hopefully you know that b is 16, right? That's b, that's 16. You can take 16, you're going to cut it in half. In step 4, it says find b over 2 squared. By the way, 16 over 2 is 8. So you're going to take your 8 and you're going to square it, and you're going to get 64 because 8 times 8 is 64. I have noticed a handful of my students do not know their squares. That's kind of sad. You need to work on that. It's 64. If you use a calculator, pay attention to the calculator. It can teach you things about numbers. It can. So we're going to add that to both sides in step 5. Now the right-hand side should be 36 if you put it together. The left-hand side factors as x plus 8 times x plus 8. Pay attention to this. Remember me talking earlier about half of b? As soon as you figure out what half of b is, you actually know how the polynomial factors. This one's quadratic. But if something is squared, that means that it was written twice. Or if something is written twice, it means it's squared. Sorry, I'm tired. So we just did step 6, and we put it together as a square. Step 7 is counteract squaring, by square rooting. Not everybody knows that, and that's kind of sad. It is. Fix that problem. The opposite of squaring is a square root. Remember, the fundamental theorem of algebra says that that has two solutions, so you had best include the plus or minus symbol, otherwise you're only half correct. The square root of 36 is 6 because 6 times 6 is 36, and the square root annihilates the square, and that gives us x plus 8. And our last move is to counteract the addition or subtraction, so we're just going to subtract 8 from both sides. So x is going to be a negative 8 plus a 6, or a negative 8 minus a 6. Now, negative 8 plus 6 is going to be negative 2. And negative 8 minus 6 is going to be negative 14. And those are the two x values. It's exciting stuff, isn't it? All right. We've got a couple more of these. Solve 2x squared minus 4x minus 62 by completing the square. So pay attention to step 1. If a is anything other than 1, divide it out. The complete the square technique, at least the way I teach it, I don't teach it the way I was taught it because y'all's mental math isn't what it used to be, is to divide that out. So a step-by-step process. Step 2 is to move that 31 to the right-hand side. X squared minus twice x is now equal to 31. We're probably going to get a funny-looking answer on this one. Now we're at step 3, divide b by 2. This is b. b is negative 2. You're going to take a negative 2, you're going to cut it in half, and you're going to get negative 1. Step 4 is to take that negative 1 and square it. A negative times a negative has always been a positive. And step 5 is to add that to both sides. Why do we add it to both sides? That was the question. Why to both sides? Why? Hopefully you're saying equality. You have to be fair and balanced here. It's balanced equations. Right-hand side is going to make 32. I know factoring is something y'all struggle with, but to make a 1, it takes a 1 and a 1. X was x and x. 1 is 1 and 1. To add to a negative 2, they're both negative. And again, establish that connection. As soon as I know what half b is, I actually know how it's going to factor. For the third time, if something is written twice, it may as well have been squared. We're not actually doing standard form. Somebody's going to do standard form on this sheet of paper. And now we're ready to counteract the squaring operation. The opposite of squaring is square rooting. Do not forget the plus or minus symbol. The square root annihilates the square, gives me x minus 1. We go back to 9th grade and we think about what the root of 32 is. The root of 32 is a root of 16 times a root of 2. And you are expected to know what the square root of 16 is. Like you're 16, 17, in some cases 18 years old. The square root of 16 is 4. You cannot take the square root of 2. I have had so many kids over the years tell me they knew how to take the square root of 2. And you ask them, and they don't know. It's 1.414 something. That's all I can tell you. It's not a pretty number, kids. But anyways, x minus 1 is equal to plus or minus 4 roots of 2. Do not forget the plus or minus 2. That comes from the square. And now we are going to jump equality with our negative 1 because we are counteracting subtraction with addition. That makes it positive. And it is very good practice to write your answers out separately, even though you may not know what they are, right? So one of your x's is 1 plus 4 roots of 2, and the other one is 1 minus 4 roots of 2. I think radicals is something that just bothers kids. Like, you want to know what it is. If you want to know what it is, go push buttons in your calculator. But do not write that decimal down for Milbrath, because Milbrath doesn't want your decimal. I do not want the decimal. I want you to get comfortable with radicals. Radicals are perfect. Radicals are exact. Radicals are not rounded. Anywho, moving forward. I'm just going to pretend these steps don't exist because they'll just slow me down talking about them. Gone. We're going to divide everything by a 5. Hopefully this one's imaginary. That's the first move. The next move is to get the constant on the right-hand side. The next move is to come off to the side and find b over 2. And b over 2 is, went too far here. It's 4 over 2, which is 2. Now, I know that b over 2 is 2. So believe it or not, I know that a line in the future is going to say x plus 2 squared. Now, after I figure out half of b, what I was supposed to do is I was supposed to take that 2 and square it and get a 4. And that 4, for the purposes of equality, was to be added to both sides. Oh, it's not imaginary. And then 2 plus 4 is 6. This is just a funny looking answer is all this one is. I really thought one of these was imaginary. But it's not, is it? Bummer. All right, so the opposite of squaring by now is square rooting. The square root annihilates the square. Do not forget the plus or minus symbol. So x plus 2 is equal to plus or minus the square root of 6. Counteract addition with subtraction. X is a negative 2 plus a root of 6, or it is a negative 2 minus a root of 6. Whew. All right, I got 2 to go. Johnny. This time Johnny is jumping off a skyscraper, because he's fearless, man. He's jumped off cliffs, skyscrapers. We're going to figure out something else. I used to always have him hit the ground, but I just can't talk like that anymore. But whatever. So we'll say the skyscraper is 768 feet tall. It would make kids remember the problems. It would, if you just cause just a little bit of trauma. All right, so he's going to jump off a skyscraper at 768 feet tall. He should say he takes the elevator to the top of the building and breaks the door leading to the roof. By the way, that is illegal pretty much everywhere. He jumps as hard as he can with an initial upward velocity of an impressive 32 feet per second. And I have all sorts of typos over here. Per second. Acceleration. Using the form height as a function of time. Notice how I read that. I read that as height as a function of time. H of t, height as a function of time, is negative 16 times the time squared plus v subscript 0. This is initial velocity. Now, we've worked with these types of equations for a couple of days. It's just time to introduce the format of them. Plus HO, most of y'all probably read that ho, it's H subscript 0, which means initial height. It is the height at 0 seconds. And we're supposed to model it with a quadratic. If you need an actual model like this, here's Johnny. He's going to jump off the building. And don't worry, he's not going to die. At some point in time, Johnny's parachute opens up. And he comes safely down to the ground. Okay? But anywho, the height as a function of time is negative 16. I'm going to switch to uppercase because my lowercase t's look like plus signs. Plus the initial velocity, which is 32 feet per second. Don't forget the t. Plus the initial height of 768 feet. I do see sometimes kids put units in math problems. We just save units for last. That's all we do. We just save them for last. All right, so hopefully his parachute opens at 208 feet. How long is Johnny in free fall? Hopefully not too long. Hopefully shorter than if it was at 0 feet when his parachute opens. Now, this, by the way, is a height. Okay, I know kids struggle. I think it's a reading issue, but what do you suppose the H stands for, children? The H is for height. We're going to plug that 208 in. We're going to replace H with that. And from here on, normally I would have you factor this one, but the lesson today was about complete the square. So we're going to complete the square, all right? And what I'm going to do is I'm going to shift everything left, because what that does is that makes that 16t squared positive, okay? Well, let me rephrase it. Yeah, we'll just go ahead and do that. It might be an extra step, but we'll do it. That'll give me 16t squared minus 32t. Remember, if you jump equality, change your sign. Minus 768, and then plus 208, because that was already there, right? We'll go ahead and put some things together. This is going to make 560, and it's negative. And then we'll start the process of completing the square. The very first step in completing the square is to divide by a. If I divide by a, that's going to give me t squared minus twice t How many times do you think 16 enters 560? How many times do you think it does that? Anybody know? Let's see, 30 times 16 would be 480, so I'm still 60 shy. So it's going to be 35. That seems right. Minus 5 equals 0. Now, the reason we're going to complete the square is because this does not factor. You need to look at that. Are there factors of 5 that add to 2? And no, there are not. We could do the quadratic formula. That's not the point of the lesson. The point of the lesson is complete the square. So the next step is move C to the right-hand side. That'll give me t squared minus twice a t, leave some space, equal to 5. Now, this one actually works out quite nice. Now we're going to find half of b. That's going to be a negative 2 over 2, which is a negative 1, which, by the way, tells me that this will factor as t minus 1 squared. And I'll show you that in a minute. We're going to take the negative 1, we're going to square it, and we're going to get 1, which we add to both sides. Now, how did I know that that factored like that? Because I've done this a few thousand times. But factors of t squared are t and t. Factors of 1 are 1 and 1. To add to a negative 2, they're both negative. And I hope you get there too. This was supposed to come out nice. I have made a mistake. Oh, it's 35. That's the problem. I said 35 and I just wrote the 5, which makes this a 36. My bad. My bad. By the way, this does factor. It does. It's going to be 7 and 5, which we'll see in just a second, okay? Anyways, the opposite of squaring is going to be the square root. Sometimes you hear me call that a radical. And if we square root a square, we get the quantity inside. And the square root of 36 is either positive 6 or negative 6 because we're expecting two answers. We are going to add 1 to both sides. We are going to be 1 plus or minus 6. Now, let's do the operation. 1 plus 6 is 7, and this is time, by the way, seconds. 1 minus 6 is negative 5 seconds. This is the real answer. I'm surprised it was that long. Have I made a mistake somewhere? No, I haven't. Yes, I have. Yes, I have. You can tell I'm in a rush. Have I? No, 1 plus 6. I was expecting something smaller. But no, it's right. So 7 seconds, and it's real. And this one's negative 5 seconds. So let me introduce a vocabulary. This is definitely the real answer. This guy is what we call extraneous, and that's a word that we need to be working on. It is a solution that happens by doing the algebra that doesn't make sense in the context of the real world. And Johnny was in free fall for an impressive 7 seconds. I don't know about you, but I'd be pretty terrified. I'm hoping my parachute opens. For Johnny's sake, I hope it did. All right, last one is to derive the quadratic formula. So let me sing you the quadratic formula one more time. She's x equals negative b plus or minus square root. My singing voice is off. B squared minus 4ac all over 2a. That's the goal. We're going to do this by completing the square on ax squared plus bx plus c equal to a 0. This is a higher level, okay? There's no numbers, it's just letters. First move, divide by a. That gives us x squared plus b over ax plus c over a equals 0. Next move the constant to the right-hand side. That would make that thing negative, right? Most kids can follow through here based on looking at instructions. Then it gets a little iffy. The next move is to find b over 2. Well, b is actually b over a. And you're going to divide it by 2. Dividing by 2 is as simple as throwing a 2 in the denominator. Our next move is to take this b over twice a and square her. B times b is b squared. 2 times 2 is 4. A times a is a squared. And we're going to add that to both sides because of equality. quality. So usually when I instruct this in class, this is about where I start losing kids. Like, I mean, they're like, what? It is what it is. Hopefully you're catching on to what's going on. Now, this thing would be just darn near impossible to factor if you didn't already know the trick. It factors, see that positive b over 2a? It factors as x plus b over twice a squared. That's how it factors. I swear it does, because that's how the technique works. This piece has got fractions, and I know how we feel about fractions. But to add two fractions together, we have to seek a common denominator. I'm going to change the order just a little bit. I'm going to make it b squared over 4a squared minus c over a. And the common denominator here would be to make this one be 4a squared. So I'm going to multiply it by 4a. And if I multiply the denominator by 4a, I have to multiply the numerator by 4a, so that I'm really multiplying by the number 1. All right, so we have b squared over 4a squared minus, change the order here a little bit, 4ac over 4a squared. Now, both of these fractions exist over a 4a squared, so we have b squared minus 4ac all over 4a squared. And hopefully you're starting to see the quadratic formula come into play, because she is starting to show up. We see this piece right here. Anybody remember what you call that piece? Do you? B squared minus 4ac, we had a lesson on it. Discriminant, that's right. I'm just going to assume you knew what you were talking about. That's the discriminant that determines the nature of the solutions. If it's equal to 0, 1 repeated real solution. If it's bigger than 0, 2 unique solutions, both real. If it's less than 0, 2 imaginary solutions, no x-intercepts, no payday. All right, where was I? I'm trying to get out of here, right? The opposite of squaring is square rooting. Good stuff. Now, when you're dealing with a fraction, by the way, this annihilates. When you're dealing with a fraction, you do it numerator as its own separate entity and denominator as its own separate entity. We cannot take the square root of stuff when there's pluses or minus symbols most of the time. Sometimes you can, but it's past the scope of Algebra 2 by and large. We're just going to have the square root of b squared minus 4ac inside the radical. Notice that was a square. That's where the plus or minus symbol comes from, the two solutions. Down in the denominator, I know and you know the square root of 4 is 2, and I know and you know the square root of a squared is a. And it's looking a lot like the quadratic formula. Now, the opposite of addition is subtraction. And if you lived anywhere else in the world besides the great United States of America, this is how you would learn the quadratic formula. This is how it's taught. So far as I know, maybe it's changed. At least this was a couple years ago. That's how they teach it. What they're trying to do is they're trying to say, kids, it's the vertex. Remember, this is the vertex plus or minus some number to get to the x-intercepts. They're trying to reinforce the concept of symmetry. Why in America we don't teach it that way, I don't know. But I'm not in charge of education now, am I? And that's probably a good thing. But anyways, since both of these pieces exist over 2a, you are able to unify the two fractions into a singular fraction that looks like this. X equals negative b plus or minus square root b squared minus 4ac. Forgot the c. Good thing I sang the song. All over 2a. All right, I hope you enjoyed that lesson. Whether you're a student or a parent trying to help your kid learn, I hope you enjoyed. Later.